momentum. Mathematical simulation. In the investigation project carried out during spring 2001 with the aid of the Fundación Retevisión and the collaboration of the Investigation Center CARTEF of Valladolid, the head of the Department of Mechanics of the Institute of Mechanical Engineering of Valladolid realized a computer simulation of the behavior of different rotating objects, provoked by new torques in accordance with the conceived theory of dynamic interactions. The third simulation model was a mobile in space with an intrinsic rotation and subject to a new non-coinciding torque. In this case, as foreseen in line with the theory, the mobile would trace a closed path similar to the orbit traced by an object in space, subject to a central force. The importance of the linear speed of the solid to trace this path was observed. So there was the new challenge for our investigation, reproducing this path. Final tests. We used as a test tool a cylinder or submarine with longitudinal rotation and linear movement, equipped as well with a gravitational torque perpendicular to the rotation axis. The submarine was equipped with radio-controlled speed. The motor for the actioning of the propeller itself, by reaction, made the object turn in the sense opposite to the propeller on its longitudinal axis. It did not have any rudder nor any other steering mechanism. In September 2001, the tests started in the test canal of the Naval Engineering School of Madrid. When the submarine was still, as in that case it was in balance, the gravitational torque made the stern sinking, staying vertically with the bow floating slightly. However, the dimensions of this canal were not adequate as the submarine did not have enough amplitude for the turns. Therefore, and following two tests in the mentioned canal, the final tests were carried out in the pool of the Isabel II Canal of Madrid on October 18th and subsequently in Altea, Alicante on November 8th. During these tests, we were able to prove without any possible error of interpretation that the mobile with own rotation transformed the action of the second torque into a movement of precession, adding the linear moving speed to the centripetal acceleration produced by the interaction torque. When the motor was started, the mobile was righted, starting a flat navigation on the water surface, with a closed path which radio varied in function of the moving speed. When the turning sense was modified by changing the driving propeller, the path of the turning sense was modified as well. The traced path was circular, but changed into an elliptical form when changing the speed of the mobile. Thus the computer simulation done before was confirmed, and the laws stated in the theory of dynamic interactions to understand the behavior of objects with an angular momentum were successfully tested. The first tests with aluminum cylinders, provided with an initial rotation, showed an inertial resistance which prevented the composition of rotation. Both rotations, the initial and the one generated by the second torque, were kept simultaneously, without a vectorial addition. Moreover, the rotation generated by the second torque did not correspond to the laws of classical mechanics, nor with vectorial algebra. The second rotation was produced around an axis perpendicular to the second torque and not in the direction of the axis of the torque. It has been checked that such a dynamic situation can, under certain circumstances, be found in artificial satellites. However, in the initial experiments with cylinders semi-submerged in water, the mobile did not have an initial linear speed. With the so-called submarine, we disposed of a mobile with linear speed of a constant torque which kept the rotation speed constant around its longitudinal axis, and of another constant torque, gravitational, which generated a new rotation around the axis perpendicular to the linear speed. When observing the behavior of the submarine, imbalanced and propelled with an electrical motor which simultaneously generated its rotation movement around its longitudinal axis, it was observed how both rotations around the perpendicular axis were kept, but the rotation due to the second torque did not have as an axis the axis of the torque, but another perpendicular one, and was added in a selective way with a vector of linear speed, generating as such a precession movement simultaneous with the rotation, modifying the turning sense of the initial rotation or the one of the second torque. The direction of the resulting precession movement was changed. After these observations, it seemed that the generalization to the objects in space was feasible. The dynamic analysis of the behavior of the gyroscope could also be applied to any other object in space with an intrinsic angular movement. We would like to underline here the resulting contradiction between these tests and classical mechanics. In classical mechanics, the gravitational interactions are not changed by the movement of the objects, even if this movement is the rotation, nor the movement itself generates any interaction, and therefore a rotation movement around an axis would not generate any force at all in classical mechanics. Including if a torque is applied to a solid with a linear movement and an intrinsic turn, these would cause a new rotation to the solid, which would be added vectorially to the existing one, but which would not modify the path of its center of masses. In rational classical mechanics, if there is no force applied to the center of mass of the solid, this will not modify its path, nor will it therefore realize any change in the path when subject to external torques, changing only its intrinsic turn as a result of the vectorial sum of the initial rotation and the one induced by the torque. We are of the opinion that such conclusions of classical mechanics were not compatible with the behavior of the spinning top or the gyroscope. The question was raised if this behavior was a singularity of these objects. We could not understand that these objects would have a specific dynamics different to the rest of mobiles. The movement of the cylinder equipped with an own rotation and linear movement was obvious. It traces a flat path which was apparently circular. Modifying any variable, the path was changed. If the linear speed was reduced, the path changed into an elliptical form. When the movement was stopped, the mobile stayed vertical, riding again when the propeller started its impulsion.